because they're no longer like, I remember one answer was 1119. No, that one's gone. There's virtually nothing that has an answer that's just it's no longer like. All right. Am I sharing screen? I'm not sharing screen. All right, so let's talk about this test a little bit. So if it's what I think it is, it's 20 questions plus one. Let's say 21, but that's just the one where you put your Desmos files. It's not worth any points. There's like 4 of each type of question. There's like 4 vocabulary, 4 say out loud, 4 what happened here, reading comprehension, 4 written answers, and 4 take the data and present it. Most of the presentations are present as the speaker. So all of those will start with according to whatever regression, bless you, according to whatever regression, blah, 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 blah. Okay. Any questions? Questions? So let's take a look at quiz 7 that expired. See how it reads you. Yes, but I wanted it done today. You couldn't do it today. I can reopen
today.
I can reopen till the end of the day. I just wanted stuff done before class. And I wanted it done before class because I don't want people do this and it really pisses me off. I'm sitting in class telling you all the cool things that are happening on the test and you're at home taking a quiz. That's what people do. So I have to stop the quiz so that people don't decide to stay home and do the quiz and then not listen to all the cool stuff that's going on in class. That's why. So let's take a look at the quiz. Especially since I would write the test after, I would write it tonight so you wouldn't know what's on it. Because I have a tendency of telling you things like I already did with that no epsilon delta thing. But normally I wouldn't know that. But I happen to know that. So I'm blabbing. So this is a good time to pay attention or to watch this video because I can't help it tell people my stuff. Okay, so let's see. We're looking at the quiz. We're looking at the questions people didn't get. Oh. Okay, so this question I named delete me before using again. I obviously forgot to do that. So somebody got it. And the question is, what undoes a derivative? Yes. But it's once reduced variables in main form. It's wrong. That's why it's wrong. I can't fix this problem. It doesn't want to be fixed. All right. Sometimes Blackboard just insists on not fixing stuff. I don't know what to do about it. Okay, the three-sided fence is built next to a section of river. Okay, they give you Desmos formula, so I'll just put that over here. And I'll say the three-sided fence is built next to a straight section of river, which forms the fourth side of a rectangular region. Okay? The area enclosed is equal to some square meters. Like the area is equal to like 200 square meters. Okay? All right, which is going to be X times Y. The perimeter is going to be, since it's 3 sides of a rectangle, 2 of them we'll call X and 1 of them we'll call Y. It doesn't matter whether you have 2 X's and 1 Y or 2 Y's and 1 X's, but we're going to say 2X plus Y. Does everyone understand that? Three sides. Okay. That is a function of two variables, x and y. What I want is to write it in terms of one variable. So I happen to know from line 20 that I just deleted, I happen to know that 200 is equal to x times y. So y must be equal to what? What's y equal to? If 200 equals x times y, then what's y equal to? 200 equals x times y. What does y equal?
200 over x.
Thank you, Nan. 200 over x. Okay, that's what I'm going to put in for y. Okay, that's the whole hard part of this problem. Because now all we have to do is look at the graph. There it is. And where's the minimum? At 10. So x equals 10 is the minimum. What if they want the other dimension? What's the other dimension? Well, I just said y equals 200 over x, right? So that equals 200 over 10. That's 20. Okay, so x equals 10 and y equals 20. And if you multiply them together, you get 200. All right, any questions on that? 3 people got it and everybody got it wrong. Okay. What about the next one? Oh, the sheet of paper. 4 people got this and 4 people got it wrong. Sheet of paper is a definite, it's a definite question that could be on the test. Okay, so I'm going back here. Sheet of paper, I don't know, 25 by 11, let's say. It's made into an open box. There's no top. Okay. So you know that they want to maximize the volume, right? Maximize volume. Volume of a box is what? What's the volume of a box? Length, width, height. Length, width, height. That's a function of 3 variables. That's L, H, and W. Okay. How do I get it to one variable? When I constrain it with that box, I have a few constraints. One of the sides, the length, is whatever it was, 25, but I'm taking 2 x's off of it. So that's one of my constraints, is that the length is equal to, it was 25, but now I'm taking away 2 x's. Okay. The width was 11. And what am I going to do? By making it be part of that box, I'm taking away 2 x's. And what's the height going to be? When I fold it up, what's the height going to be? No. I have a side, and I've cut these x's out of it. So 25 minus x, and then I'm going to fold them up. So this width is x, then I fold it up. So what's the height going to be? That's it. Which is it? Well, it can't. It's not 25 or 11. It's just x. It's just x. Take an x here, take an x there. When you fold them up, that's how height is. That's the height x. Okay. You understand? I don't have any paper. Paper would really help. There, okay. Okay, so these are made, this is origami to make. They're clearly doing funky stuff. Let me see. Nope, nope. I thought I could get something cool out of this, but I'm not. Let's see. Oh, here we go. It's this one. It's a pretty picture. And then it has everything. Do you see what's going on here? I'm cutting squares out of the corners. And then I'm folding it up. Where's a nice picture of it? Okay, do you see what's happening? I fold up. There, no, I don't see a crease on any of them. That's too bad. What they're not showing you that I would have liked is okay, what they're not showing you is a crease here. They're see that? They're bending it there and there. Okay, that's the bottom. Okay. And so, but none of these pictures actually have a crease. I don't know why my pen is so huge. Oh. All right, so do you understand that now? Sarah, are we good? Why are we hiding our face? We're not trying to fall asleep, are we? Okay, so that means if I want the volume as a function of just x, it's going to be one side, 25 minus 2x. It's another side, which is 11 minus 2x, times the width, the height, which is just x. Okay? Now, what do they want from us? Okay, so I don't even know what that is. The heck is that? They want us to find the maximum volume. So I can zoom out or zoom in. What do you think? So here's what I do. I go into the y coordinate thing and I just make it bigger. 9, 9, 9. See, do you see maximum now? Right there. 2.38. That's the size of the x. That's the height is 2.38. The 300 is the volume. Okay. I mean, look, let me just do this from table thing. If you can't do 2, -2, right? That ain't happening. The smallest you could cut is 0. Why isn't that working? Is V in more than one spot? Really? Where? I'll call it F then. Okay. When I cut nothing, the volume is 0 because I just have a piece of paper that has no volume. If I cut 1 inch, that means I fold it up 1 inch. So it's 1 inch high times whatever the base is. The base is going to be 23 by 9. So 9 times 23 times 1 gives me 207. Okay. When I cut 2 inches off, it's going to be 25 minus 4. That's 21 inches. Minus, or times 7. That's 21 times 7. And then that's going to be times 2 inches. That gets me a bigger size, 294. But if I cut 3 inches off, it's coming back down. 4 inches off, 5 inches off. See what happens eventually. If I get to 5.5 inches, it's going to be 0. Do you know how I know 5.5 inches will give me 0? Because one of the sides is 11. 11. If it's 11 and you're cutting 5.5 from one side, 5.5 from the other, what's going to be left over? No, there's nothing to fold up. Okay. Any questions on that? I like both of those questions. Wink, wink. You won't necessarily get both of them. I told you, so this is what I'm going to tell you. There aren't as many questions as there are different answers. So the questions say the same, but you see how they have this problem had a little A and a B, and I put numbers in for them. You'll have different numbers, but the process is the same. It's not that many questions for me to ask that I was happy with. Okay. This one. What's happening in line 17 and 18? What's happening here? Nothing. So they just took the derivative. I don't think that there's a particular good choice for this. The answer is not quotient rule. Oh, the answer says quotient rule. Oh, it is the quotient rule, isn't it? Hold on. That's a rational function. It is the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. It's the quotient rule. Who knew? But for finding max and mins, we don't need to use the quotient rule. Just get it right off the graph. Okay. '23 and '24. What happens here? I'm looking at you for a reason. Not because you're hiding out. I'll call on somebody else. I'll call on somebody from home. How about Jake? What's going on here, Jake? Jake. Jake's like, what?
Are they reversing the derivative?
No. Nice guess. But no, between lines 23 and 24, what happened here? I see an antiderivative in 23. I see the same antiderivative in 24. Ain't no antiderivative been done. So that's not the answer. There aren't a whole lot of choices. Shall we look at the choices? Finding critical points for optimization. Critical points and integrals? No. Using constraint to reduce variables? No. Optimize for the second derivative test? No. Quotient rule? No. Antiderivative? No antiderivative. So what's left? That's why I was looking at you. You said everything like algebra last time. Because algebra was well, why didn't this make sense then? Because that's totally what this problem was. It's just algebra. What's 1/4 plus 5/4? 6/4, which is the same as 3/2. Well, because all power will change, but if the antiderivative was done, the antiderivative goes away. If you done the antiderivative, you would have that integral thing hanging around. All right, let's go on to the next one. These are still zeros. Okay, this is COVID. And say your prediction in week 5. So this is week 5 of COVID cases. So let's see what we got. Week 5, what are they saying? Let's expand this so we can see the whole thing. Okay, so is this what's being said here? Is this one of those, accelerating things, or is it something else? Does anyone recognize what this is? the function, the derivative of the function times a half. And then this stuff right here, what is it? It's error. So what they're saying is, they're saying, make according to the what regression, the number of cases will be what plus or minus what, which represents a what percent error. So according to the what regression, cubic regression, in the fifth, whatever this is, week, it says weeks there, in the fifth week, the number of COVID cases is 194 plus or minus 72, and that represents a 37% error. Okay. So let me tell you about some of these questions like this one. If the question has a lot of parts, I'm going to ask you for one part and ask you to present it. But if you remember all the parts, you should say them. So if I just said for this one, I might just say, what's the number going to be? And you would say, well, according to the cubic regression in the fifth week, there's 194 cases. But plus or minus all these other things, which is what percent error. Okay, you can say it even though there's not going to be spots for it. All those numerical ones have no spots for you to write anything. And they also don't have spots for me to write anything. They just have a spot for a number. So and it can only be one number. So if I ask you to present it and there's more parts, you should say them. You have them, you should say them. But you can't put them all into you only put one number in. Put the right number in. Okay. All right. So according to cubic regression, the number of cases will be blank, 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 blank. Okay. Next, another 0, maybe. 1/5 of the people got this. Same thing, except in the 7th week. Predict the number of cases in the 7th week and the error and the percent. So this is just the same thing, only with a 7 in here. 431 cases plus or minus 47 cases, which is 11% error. Okay. 47, 431, 47, 11% error. Okay. What happened in lines 20 and 21? Okay, I'm opening them up. Who's going to help me with this? Somebody from home, maybe? I got 7 people. Suhabe, you're a winner.
Hi.
So, what happened here? Lines 20 and 21. You need the choices? Okay, is it algebra? Is it the quotient rule? Is it antiderivative? Is it what were the other things? Hold on. Algebra, finding critical points, using constraints, quotient rule, optimizing the second derivative test. One of those things I said, Suhabi, which one is it?
I'm not sure. I think I actually got this one wrong, but I think I like kept getting this one wrong, but I think I put antiderivative.
That would be correct.
Oh.
Oh, I'm trying to help you, by the way. I told you, my pre-calculus guys were so surprised yesterday when I told them I watched these tests. I watched all your room scans, all of them. So I don't care if your room is messy. My room is messier, I assure you. I do care if you have papers on your desk where you're working. I do care if you're at a bed taking a test. Some people take tests on bed. You can't scan your bed. There's always something. I'm like, well, what's under that pillow? Like you can't You just can't scan it, but, and then the problem with that stuff is I watch it, I make note of it, but then Honor Lock comes on later. Then they say, get out of bed. Because you're not supposed to be in bed, you take the test. So sometimes you're wearing a hat, sometimes they catch it, sometimes they don't. You're not, I mean, the goal of look, as far as I'm concerned, I watch the room checks, the room scans, because it tells me how serious you are right away. If you're serious, you want to show every corner of the room, you want to make it look like you're very serious. Like, look at me, I'm not cheating, look under the desk, whatever. But if you go haphazard on it, then I'm like, okay, then you're taking this test probably haphazard. And then I just, it's like an interview. It's like if you come to an interview poorly dressed, I can't grade you on poorly dressed, but I can get a feeling for how you feel by how you do your room scan. So I watch the room scan. Don't care how you dress. Don't care how messy your room is. Do care that your table is clear. Okay, don't want to see a lot of crap. I think I've seen your chalkboard wall. Have you shown it to me? Was it, somebody showed me every single picture on the chalk. That's too serious of a room scan.
I did not.
And then somebody did that to me. They did the room scan. They showed me every little nook and cranny. Like, here's my pencil holder. Look inside. And then they, right after they put the computer down, then they turned and went and dug something out of somewhere. And I was like, what the heck did you just do? What did you do? You just, you're not supposed, you're supposed to scan the room and then not go digging for stuff. And so anyway, I watch them. I make notes. I put them, I should have sent the notes to you. So you don't make the same mistake, but just because Honor Lock lets you go, and just because I let you go, doesn't mean it wasn't noticed. Honor Lock has people all over the country or all over the world, and they pop in when they have somebody free. But if the person doesn't get free before you finish the test, then you're off the hook, but it doesn't mean they won't do it next time. And okay, so I watch all of those, and then I have to watch every single one of those ones where you're talking to me. Just can't not watch them. And still, I feel like I think my online class sometimes thinks that I'm not watching them. You should never curse at anybody. You should curse at me. But I don't care if you curse at me. But if you curse at an Honor Lock person, then they report you to the dean. Yes, they're very serious. But you could say,
You can't curse inside the test, like, you just, like,
Yeah, what if I was like?
yeah, yeah. People do it all the time. It's okay. It's just if you curse to them, if they come on and they text you and they say, hello, time for room scan, and you get all mad because they're interrupting your test. It happens. I know, because when that happens, you get a violation and then I have to watch it. But the worst thing is you get a violation from them, they send that to the dean's office, and the dean's office contacts me and they say, oh, that student was really bad. And then they ask me, should we report them? Should we do bad things to them, like kick them out of the school or something, or have a meeting with them so then I have to meet with you and tell you, don't curse at the Honor Lock. So don't curse at the Honor Lock. There's people there, and they may not seem like people. You may think it's AI, but there are people at the other side of that. But they don't intervene. More than likely, I'm the one who's going to watch it, because I have no social life. Speaking of which, you took the practice. I'm going to go over the practice test. I just couldn't.
yeah, it was practice. I did.
Well, I'm going to go over it, but then I'll open it again. I'll open it till midnight, but I can't grade it. Somebody actually asked me if I was going to grade it. I said,
Can we submit it again?
no, I have to.
Is it graded?
Oh, we did it.
It is, it's graded by me once. You want to take it again? I'll grade it again. I'll grade it. It's been open since last class. I said it had to be done before class. I was going to go over it today. I'm going to go over it today. It's not, I said it. It's not just a practice test. It was the actual midterm that I gave last semester, which was over the summer, which was only like 3 months ago. This test is still smoking, but I have decided to put it to rest. And so I gave it to you as a last hurrah. And then you did badly on it. Well, I'll go over it. That's what I'm going over right after this.
Yeah.
The quiz.
I'll reopen anything you want, but only till midnight. After that.
Questions are actually on midterm, like 20,
Honey,
20.
you came in late when I said 20. I've been saying it all along, right? But didn't I? Word. Wow.
No. He was going through like some.
No, it was always been, look, there's 5 different types of questions. On the derivatives test, there were 3 of each type. On this test, there's 4 of each type. On the final, there's 5 of each type. If you want 40, I'll give you 40. It's really, the problem is, I gotta tell you, even on this test, just between you and me, there were a few questions I did and I got tired and I couldn't do anymore. So instead of making, there's like 6 or 8 version things in the pool, I said, just give them 2 of these. But I'm going to tell you what happens when I say that. When I say to Blackboard, just give them 2. Sometimes you get 2 with the same question. So mostly it doesn't give you 2 of the same, but sometimes it does. You do it twice. Don't be like, I did this one already. I'm not going to do it again. You'll hit submit and then it'll look like you didn't hit submit. And you'll say, oh, it must have erased my answer. Let me put the answer in again. Just put the same answer in. It just means the question's worth twice as much. It's not. But I tried to do it because I'm still trying to give you 4 of each type of question. Later on the final, I will do 5. Sometimes I do more of the writtens.
Do we have another test after this, or
You have one more test after this. It's called the final. This is your practice final. Between now and then, there's 2 big things that will be coming up. One is your project, which should help your discussion grades for those of you who aren't doing your discussions well. And then there's a practice integrals test, but there's no integrals test. The integrals test has been sent away. So it's like it's just practice for you.
like graded as a quiz, or
Maybe if I want to spend all of my life grading your papers, because as it stands now, those exams that are meant to be exams are not like the quizzes, they grade themselves. I have to grade them. And there's a lot of you. You only see a lot of you here, but I have 4 sections of calculus. So I have to do, the other classes are all bigger than yours. So
did you say that you give points just for answering the question?
I said I wouldn't give part credit.
Part credit?
Yeah, that's not good. You're thinking I give you points for just answering. No, I said it's either right or wrong. So if you do everything right and just make one little mistake, it's all wrong.
Seriously?
I'm maybe not. The problem is I have to mark them wrong if I want you to see what you got wrong. So I have to, it's all just a matter of for you. So if you made a mistake that I don't think is, I won't mark it wrong, but if you make a mistake that's serious, even if it's small, you need to look at that. This is a practice test. It's meant to be looked at. That, can I move on? Am I done with these? There's 50% on this one. Say this. Really? 50% of you missed this? How would you say this? Melanie, can you say this? Integral. Integral of 3x. Do I what?
Got question wrong, but it's right.
If it's one of these multiple choice ones, no. But if it's one that you speak, then I listen to you speak. This, you got it, picked an answer that was right, but it might be wrong. You can't. This is multiple choice, so you can only pick you can click on one of them. You either clicked on one of the other ones, which was wrong, or you wrote it yourself somewhere, but I don't have that. There's multiple choice ones still. I don't have any. This came from a quiz. This is a quiz. So for the quizzes, I told you these things to be said are just multiple choice. On the tests, they're to be said. So you can get part credit on them, but here, no. Just because I want the quizzes to be graded by you, but anytime I give you a test that I did before, it's not multiple choice. And it means I have to grade it. Or you just sit there. I don't know how you did know you did badly because it won't tell you. Can't tell you anything. All right, 2/3. Last one. How do we represent an antiderivative? How do we represent it? There's choices, but if I show you the choices, you'll know which one it is. How do you represent an antiderivative? The integral
Notation.
notation. Okay, indefinite integral. That's the correct answer. Somebody picked something else. But the third person didn't pick anything. Okay. All right, any questions? All right, this one. Integral of f of x dx equals what? Thank you. It's capital F. All of the antiderivative. Uh, 75%. I'm done with this. Okay, can we move on to the test now? So they're all in the same spot. So in mod 7, you've got all types of stuff going on in mod 7. You've got your practice midterm right there in mod 7. It's right at the top. Who'd have thunk it? Shall I go over that? Okay. Delete me before you. That was on this test too. What undoes the derivative? This looks an awful lot like, no, this is quiz 7. Never mind. This is item analysis quiz 7. Did I ask for an item analysis for the practice test? I did not. Thought I did. Okay, here it is. That was predict a limit. Okay. Click on the file. This is the one I told you can't just memorize because they're gone. If I click on this, I'm predicting the limit. What am I going to do as x approaches what? 21. So I just go in here and I type in 21 onto the table. And I get 1119. Easy. What if it said as x approached 5? You would type in 5. All right. If it's up, but wait, this is a limit. And on the test, it will very clearly say whether you should say it as a speaker or a writer. If you're doing it as a speaker, it says, you're going to say, as we approach the 5th hour, we'll travel 350 miles, according to the quartic regression. So that's what the speaker has to say. So start with the quartic, whatever. What's the writer going to say? If I ask you to write it, what does the writer say? And remember, you're presenting it verbally. For this sort of question, there'll be a box for you to type in 350. There won't be a box for you to write it. So if you're writing it as the writer, you have to say the limit. This x goes to what? X goes to 5 of f of x equals 350. Don't forget the units. What's the units here? Okay, So if you're asked the question, I'm saying, but the question is sort of given to you that way. You just say the limit as x goes to 21 of q of x equals 1119 miles. That's how you present it differently if you're asked to present it as a writer.
So there's no longer that little box that you can type on.
There's no boxes for you to type in.
So we have to do, like, if we're gonna write something like that, we have to do it.
Yes, exactly. I don't have to say that. She said, if I want to write it in Desmos according to the blah, 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 blah. Yes, thank you. So there's just no box in Blackboard for it, but you write it in Desmos and you attach it, and that's fine. Okay? Because you can write it, you can say it. And then write from there. If it's, remember with the presentation ones, it's the last thing you say that counts. This is, you know, I was talking to some business people about this, and this is like, in business, you have plenty of time to do a presentation, lots of time. And that's the way you should feel about these presentations. Here's some data, you process the data, you do your work, you sit around, you can buffle with it for a while, and then when you're ready, you say what you need to say. But the last thing you say is your last word. So that's what, if you don't like it, then you say, oh, no, I want to do that different, and just do it different. But I just rewind till I hear you say something. So please, when you're done saying it, move on to the next question, because otherwise I have to rewind forever. I spend a lot of time looking for answers, but isn't that life? Okay, three-sided stream. This one would not be one you have to present. This one's just, would be a written problem. It's an optimization problem, so you just have to find the answer. Do I have to do it again? We did it already, yes. Do you remember how to do it? P equals 2x plus whatever that number is that they give you over x. See it so many times I know how to do that problem without even, oh, what about this one? Oh, the car traveling one. Yes, the car traveling one. What's that formula that we all have memorized now? I don't tell me you're looking for it, because it's not on your formula sheet, because you're supposed, the formula sheet has the one, the x squared plus the y squared equals z squared. That's the formula that you're supposed to start with. But since you know it's going to be on the test, I expect that you memorize this formula that looks like x prime plus y prime all over the square root of what? That's the formula you want. So you just type in the numbers that they give you. Whatever numbers they give you, you plug in there. Okay, so and again, you can copy these into Desmos. And it may or may not work. So you may have to put things in. It may not carry the things over, but I think it does. Okay, 75.5, 72.2. So I go to this formula. I type in 75 times 5. 72 times 2. What goes in the bottom? Which ones are the values? All you have to do is not screw this up. In other words, some of these are rates and some of these are values. Which ones are rates and which ones are values? 75, is that a rate? Kilometers per hour? Sounds like a rate to me. So 5 and 2 must be the values. And there's the answer, 96 miles per hour. Okay. Look, even when I put it in Desmos, I put it in that way. Okay. Not Desmos, Blackboard. This is an interesting related rate. So that one right there was a related rate. This is also a related rate. And it's a little tricky. They give you this formula for this is suppose the average yearly cost per item of producer is this. And they tell you an X value, X equals 5, and it's changing by 2 items per year. Find the rate of change, the average, the rate of change of the average cost. Okay, so here's what I'm saying is I can copy this formula down and I can put it here, and there's a graph of it, but that's not what I want. They're telling me in this formula, they're telling me how much things are changing by in time. So they're saying the production is 5, that's a value, but it's increasing rate of 2 items per year. So I'm going to take a derivative, but it's not going to be dx, it's going to be d what? Per year is a measure of what? Years. A measure of what? Time. So I'd say derivative with respect to time. Okay. Okay, so now what's the derivative? So now I have what I'm looking for, dc dt. dc dt equals, what's the derivative of 15? Nothing. What's the derivative of, what's the derivative of 100 over x? That would be x to the -1. So I have 100 over x equals 100x raised to the -1. So that's a power rule. So when I take the derivative of it, I'm going to bring the -1 down, and I'm going to get minus 100 x raised to the what? No, that's negative. No, it already is -1. You subtract 1 from -1. What do you get? -2. Okay, but normally that would be okay if the variables match. But since the variables don't match, in other words, I take the derivative with respect to t, I should have something dt at the end. Something dt. And what would it be? Something dt. I have to take the derivative of the inside. So the inside is just x. That's what rule. So this is a power rule, and then a what? Chain rule. You're the only one who's looking at me, nobody else. Okay, so now I can use the information. Now I have the formula that I want, and I can plug in the stuff that they tell me. X is 5. X is 5. So I have to just put this in here. Times 5 raised to the -2. And dx dt is the rate is increasing by 2 items. So that's what I'm looking for. That's the answer. It's -8. Okay. All right. Any questions on this? That's a good question. See, in the formula, see, the answer is just minus 108 to the -2 times 50. Don't memorize this formula, let's just try to figure it out. All right, Newton's method. I love Newton's method. I'm sure there's a Newton method on it. Okay, so I have to copy this function over. Okay, Newton's method, Newton's of x equals. Okay, so there's my Newton's method. There's the function. All right, where's the 0 going to be? looks like it's here at minus 3.14 something something. That's 5 decimal places. Look, I don't have time for that Z stuff. Honestly, I can go right up here. The top Newton's method is this formula right here. I'll just plug in that value here. Plug it in here. Plug it in there. But remember, I used n for the function n. And so the answer is 3. That's what it is to 6246. So it's really 1, 2, 4, 2, 4, 6. I think it's that. And there. Oh, why did I even bother? It's the answer right there. Okay. You have to use Newton's method. This was definitely Newton's method. I used it once. Because Desmos is giving you 5 decimal places. If I wanted to make you work harder, I could ask you to do 8 decimal places. Maybe I'll change it to that. Newton's method again. Do I have to do Newton's method again? I don't think so. Remember, it's just the formula. I promise you on your test, I shouldn't promise anything. But if you are given a function and you can see the 0 that you're looking for, okay, that's going to have 5 decimal places. You just have to put it into Newton's method once, which again is just, it's the first formula on the formula sheet. Okay. What else? Oh, I don't remember seeing this on the test. There's hyperbolic sine is definitely on the test. I remember seeing this one. There's a point, it's one of my favorite questions. Well, there's still time to put it on. Okay. What's the derivative of sine squared of 5x? Oh, this is cinch. It's the derivative of cinch of 5x. Okay, so what's that equal to? Oh, square. What's the outermost function? The square. So you're going to use the power rule. So you're going to bring the 2 down, subtract 1 from it. Yes, which is going to give you that. What are you going to do to the inside? First, you're going to leave it alone because that's what the chain rule says. And then what are you going to do? Then you're going to take the derivative, multiply it by the derivative of the inside. Okay? So it's a power rule. You bring the 2 down, leave the inside alone, subtract 1. Okay, and then multiply it times the derivative of the inside. What's the derivative of the inside? The derivative of cinch. Gosh. And then what do you do to the 5x? You leave it alone, and then what do you do what? Then you don't leave it alone. You have to leave the inside function alone and then take the derivative of it. What's the derivative of 5x? What's the derivative of 5x? Anyone? Hold on. I'm going to call somebody at home. Don't tell me. I'm going to call on Devon. And then have a new shift next time. Devon, what's the derivative of 5x?
Five.
You make me wait so long.
Sorry.
And so what can I do with that 5? How can I clean this up? Anusha, how can I clean this up? I don't need this parentheses here, right? But that 2 and that 5, it's all multiplication, so what's 2 times 5?
10, you would make it 10.
So that's the answer. Okay. Like that one. I don't remember seeing it on the test. How about this one? What's the answer going to be for this one? You're going to bring the 2 down, so it'll be 2. Leave the cosh 7x alone. Then you're going to take the derivative of cosh 7x, which is going to be what's the derivative of cosh? Just sinh of 7x. So right now I have 2 cosh of 7x, sinh of 7x. So I'm leaving inside alone. And then what do I do? What's the derivative of the inside? 7. So that 7 at the end is going to be multiplied by the 2. So it's going to give us 14 cosh sinh. Okay. What's the derivative of 4e to some stuff? It's 4e to that same stuff being left alone times, no, 4 is there, 4e to the stuff. It's going to be 4e to the stuff that you've left alone times, you're leaving something alone, so what do you have to do with it? No, not particularly. Derivative of e to the x is e to the x. Okay, the derivative of 4e to the x is 4e to the x. The derivative of 4e to some stuff is 4e to some stuff because I'm leaving the inside alone. And then what do I have to do? Times the derivative of the stuff. Okay. What's the derivative of the stuff here? It's the derivative of 6x plus 1.
6.
So 6. So it's going to be, so the answer will be 4e raised to the stuff, which is 6x plus 1 times what? 6. Or you can put the 2 here. Get 24. Okay. And so what's this one going to be? What's the derivative of 7e to the stuff?
No.
Leave the stuff alone.
56.
7e to the stuff is the 8 is that it's going to be 7e to the same stuff times the derivative of the stuff, which you're getting 56. So what's the derivative of 8x plus 1? 8. So it's the exact same answer, just multiplied by 8. That's where you get the 56 from. Okay, it's 56e to the stuff. Find the equation of the tangent line. This is another good one. Remember if it's on there. Do we have a formula with the tangent line in it? How about this one right here, number 19? Okay. So in 19, I've got my formula here. It says the equation of the tangent line y equals. So in order to do this, I have to say f of x equals what? X squared plus 7x. Okay. Boom. Okay, there's my function. So a lot of other functions here. I can turn them off. Okay, so I got my I got my function there in purple. And then I've got my L. All I need to know is what do they want? At x equals, they want to find the equation of the tangent line at x equals -1. So that's just saying a equals -1. Okay, or I can put it in here, -1. The derivative of, hold on. The derivative at -1. And then it'll be x plus 1. So what's the function evaluated at -1? Well, right here, that'll tell me what f of -1 is if I just do it. It's f of -1. There's too many f's in here, aren't there? Where are the other f's? There's one. F of -1 is -6. F prime of -1. Okay, so let me just write this down. Copy this. Put it here. F of -1 is -6. And f prime of -1 is 5. So that's the equation line, -6. I'm not sure if they make you put it in a different form. This is why, oh, here we go. B would be 5, be x plus 1 or x minus a -1, and then that A over there would be 6. So there's, well, -6, 5, and -1. Okay. All right. This is a what rule? There's two things being multiplied together, so it's a product rule. So it would be the first times derivative of the second plus the second times derivative of the first. Okay. So this one here, you're going to take x squared plus 5x minus 9. You're going to multiply by the derivative of that, which would be 2x plus 8. So A will be 2x plus 8, and B will be 2x plus 5. Okay. Say this. Ooh. What do you think? No, just say it. That's 0. So the integral of f of t dt equals s of t plus s0. This is another way of saying this is the integral of the velocity is equal to the position plus the initial position. Is that one of the choices? The integral of the velocity equals the position plus the initial position. Whatever. Yeah. Why did we invent limits? What? The 2.21. What are other ways of saying instantaneous rate of change? Anusha? Other way,
Sorry, could you repeat the question?
what are other ways of saying instantaneous rate of change?
The derivative.
Derivative. Begins with a V. I just said it 2 seconds ago. V of t is the velocity. And the what? Slope of the what? Tangent line. Thank you. Okay. Any question? Okay. We're still in the zeros. What are some applications of derivatives? You tell me and I'll tell you whether I remember seeing them on the test. Do you remember them? Newton's method, I do remember seeing on the test. Mean value theorem, I remember seeing on the test. That's not really an application of derivative, but they're also on the test. What else? Linear optimization, yeah, it's on the test. What else? Newton's method on the test. Error on the test. Anything else?
Is the Hopton rule on the test?
L'Hopital's well, yeah, it is, but it's a limit. L'Hopital's rule is just a limit. So you can find it without using L'Hopital's rule. Nothing on it. I don't have anything on the test that says use L'Hopital's rule to determine the limit. You can use anything you want. Okay, I forget why I'm here. Why am I here? Oh, I forgot. Oh, I know why I'm here. Lessons. This is the way I find what the applications of derivative are, because when I'm teaching this class, after we do, okay, so we've got, after we do the last derivative, which is transcendentals, then we have the mean value theorem. We have implicit differentiation. Newton's method, position, velocity, acceleration, local linear, related rates. Did we say related rate? I don't think we did. Right. Right, I think that covers most everything. L'Hopital's rule. Analysis of functions. Optimization. All of them. Applications. I have to cover sigma notation today too. Okay, I'm still at zeros. Why are we still at zeros? What went on here? It's it. Is that the quotient? Of course, it's average rate of change. Average rate of change. Those were definitely on the test. Okay, what about this? What went on here? It says it right up at the top, local linear. I gotta fix those. That's right there. How local linear?
Oh.
It won't show up. That's for me. I labeled the question that. All right, another one. Say limits. So it must be a say limit. Say it. The limit. Yep. I know that on the test there's a lot of negatives. I don't know. I just remember having to be a lot of negatives. Okay. This is a say this limit. Limit is x goes to 1/2 of x equals negative infinity. Okay, so what is this? Say it. Derivative of f prime plus second derivative of g, evaluated that.
Plus, no, plus for, thing, this one, it's said for,
Your goes for
support.
fourth derivative. Yep. Right. Okay, how about this one?
Plus G. Plus.
Mhm. I usually say the derivative of f evaluated at 2
What did I say? I put two.
of.
Wait, I have a question.
What?
For the one that you just did, how did you say the one with h, like with the exponent again?
It's the, what did I say? The fifth derivative of H?
Fifth derivative of h. Can you hear her?
Yeah, kind of.
So she said the derivative of f evaluated at 2, the second derivative of g, and the fifth derivative of h.
Okay, thank you.
No problem. All right, what happened here? Yes, but which one? That's not one of the answers. Nope. Chain, no chain, no pound. Anyone? Particle. That's it. Why are all of these zeros? Did people get? Oh, I didn't even bother looking at this. Hold on. Feel like everything's a zero. We're already up to question number 24. There's only 11 questions left, and not a one of you got any of these. Just look at them. So this one, even this one didn't come in last place, and you get no points for this one. 25%. Hallelujah. Somebody got one of these. Between the fifth, what's the what? According to the regression between the fifth, the mean value theorem is satisfied. Between the 5th and 20th. 5th and 20th. So all I have to do is put in 5 here. 5th and 20th. And it's satisfied where? So I have to click on the intersections. Here's one at 8.5. So that's what the answer is, 8.5. Right? According to the whatever regression is, cubic regression or quartic regression, between the 5th and 20th hours of travel, the mean value theorem is satisfied in the, I've already forgotten the answer. 8.8 hours travel. Okay. 8.5. It also happens at 17, but it's not the first. Okay. Another 25%er. Predict the error in the 9th hour. Let's put a 9 here. And there's the error. Okay. Moving on. Okay. Predict whether the second derivative equals 0 and then talk about it. Second derivative equals 0 here. What's happening at 6.95? Second derivative is 0. So if you're asked to present this as a writer, you would say P double prime of 6.95 equals 0. That's how you say that the inflection point is at 6.95. According to this cubic regression, there's an inflection point around 7. Okay? So remember the difference, because I'm pretty sure that's on the test. One is to just say it as the speaker, so just say, hey, there's an inflection point around 7. Groovy. Or if you're the writer, you say P double prime of 7 equals 0. Okay. All right. 50%. I don't know. Oh, what's the mean value theorem say for a continuous function? So what does the mean value theorem say? Average rate of change equals the instantaneous rate of change, that's fine. Don't say too much in those vocabulary words. How about this one? The 22nd hour, I just plug in 22nd, 22, and I get all those answers. All right, I think we're done with this. That's it. Yay, any questions? All right. Let me clean this up. All right. Do you have group work to do today? Okay, everything's finished? If everything is finished, so you have no more discussion stuff to do. All right, let me just talk about the next subtopic. It's not on the test. But it will be due next, actually, I'm not even sure if it's due next week. It's called Sigma notation. Oh, let me take attendance too. What the hell? Sorry, I'm gonna ask the same questions again. I've been really busy working on your tests and I didn't do this, so I deserve to be punished. See who's here to answer the questions. Stevan! Tired of asking you this. I really, next time I'll fix these. Stevan, what is calculus?
The study of functions.
No,
No, the study of change.
thank you.
My bad.
Kara, what's changing? Not here. Mahir, what's a rate? Mahir,
There's a
answer
rate
the question.
per-
Rate is something with the word per in it. Sure. Naina, what's the relationship between position, velocity, and acceleration?
Velocity is first derivative and acceleration is second derivative.
Very good. Anusha, what does the mean value theorem say?
The average rate of change is equal to the instantaneous rate of change.
Melanie, what's the derivative of that and that? Very good. Let me try to find. Suave, what's 0 times infinity?
It can be anything.
Nyla. When can we use Nofitel's rule?
So it's
Right, and Sarah, what's an inflection point? And Jacob, what's a critical number?
X values where the derivative is equal to 0 or undefined.
Very good. All right, so this thing is all midterm review. You can look at these if you want. I would. But I want to talk to you about the next piece of the next thing we're doing. It's a lengthy review. Okay, we're doing something called sigma notation or summation notation. Okay. What it does, look, that's a Greek letter sigma. And what we're gonna do,
You're not sharing your screen.
not sharing screen, how can that be? Here we go. Okay, so sigma notation looks like a little sigma sign, and it's used to add up a bunch of things. And what we're gonna do is we're gonna look for area under a curve, okay? So you understand there's a curve up here and there's area underneath it between the axis, the x-axis and the function, there's some area. And what we're gonna do is we're gonna add up a bunch of rectangles. And then we're gonna take the number of rectangles and we're gonna let that go to infinity. So we're gonna use limits and sigma notation to find the area under the curve and thus showing why there's a relationship between integrals and area under the curve. Okay, so what's the sigma notation? How does it read? So you have the sigma, and then you have it, what's called an index. That's just a variable, I. That's the thing that's changing. So if you say I equals, then you have an A value to a B value. It's going to start at the A value. So it's going to, whatever function is inside the sum, whatever is in the sigma notation, it'll say, okay, first I'm going to plug A in. Then I'm going to add 1 to it, and I'm going to get A plus 1. And then I'm going to add 2 to it. I'm going to get A plus 2. And I'm going to keep adding these up until I get to the last term, which would be f of b. So I'm just adding them up. So let me just say what that looks like on Desmos. Desmos is where it's at. Okay. So if I have a function f of x equals x squared, and I want to add up 1 squared plus 2 squared plus 3 squared plus 4 squared. What I'm going to do is I'm going to say, okay, well, let's sum up. And we're going to start with, so our index here is n. So we're going to start with 1. We're going to go to 4. And what we're going to do is we're going to plug those numbers in to our function. Actually, we'll put an n in there. See how that works? Just added them up. This is particularly good if I want to add up not 4, but let's say I want 400. And it just does it really quickly. So, okay, the power of technology. So we're going to be adding stuff up. And for the homework that you have, mod 8 homework. Mod 8 may not even be open. I was going to open it up, but I wanted people to concentrate on the midterm. So mod 8 is still closed. Okay, so here's the homework question. It'll say something, write a summation notation for the first 215 odd positive numbers. So sum 1, I want 215 things I'm going to add up. So how do I get an odd positive number? How do I get an odd number? How about an even number? How do you get an even number? Just double. 1, 2 times 1 would be 2, 2. So if I double it and I subtract 1, what did you do? If I double it and I subtract 1, what happens to this? What does that mean? It means I plug the number 1 in first. When I plug the number 1 in, what do I get? I plug the number 1 in. What is 2 times 1 minus 1? Isn't that an odd number? Is that the first odd number? It's 1. And then the next one will be the same thing, except I'll put a 2 in there. What's 2 times 2? 4 minus 1 is 3. Is that the second odd number? Yeah. So I'm just going to keep doing that. And when I do that, Desmos will just tell me the answer. I don't even have to do it. It's 46,225. Okay. All right. This formula is already done. Just do that. There is a formula though for adding up. If you have n's and n's, there's a bunch of equations you can learn that we'll go over next time, I think. All right, what if I want to, here's a function, I want to evaluate it at 0.125, 0.25, so I want to add it up. So I'm going to do sum, and we'll start with 1, and I'm just going to put the function in here, but I want to, the first thing I want to put in is 0.125. So I want 0.125. If I multiply that by n, the first thing I'll get is 0.125, right? The second one, what will I get for the second one? times 2, which is what? 0.25, right? And then I have to keep doing it till I get to 0.75. When will I get to 0.75? So let me just pop on a table here for a second. If I'm starting at 0.125 and I'm going to 0.25, watch this. This is a Desmos thing. Once Desmos has 2 of them, it'll just automatically do the next one. I'm just hitting enter. 3, 4, 5, 6. 6 of them. So it's 1, 2, 3, 4, 5, 6. So I'm going to sum from 1 to 6 of the function evaluated at 0.125 times n. And I get 13.42. Okay, if I put this right here, f of x7, to those look at all I'm doing is adding up these numbers. I'm adding up 2, 2, 2, 2, 2, 2. What is 6 times 2? 12. And then all the little bits and pieces could add up to 13. Okay? That answers that question. This one's a little harder. I'm going to do a sum. I'm going to start with 1, and I'm going to go all the way. Ooh, I don't know how many, but I know my function is g of x, so I'll do g of x. Except I don't, the first thing I want to put in is 0.136. Or 1.36. Okay. That's fine. But how do we get to the next one? We're not doubling it this time. We're increasing by how much? How do you get from 0.136 to 0.156? 0.20. So we're adding 0.20. And then we're going to add 0.20 again and 0.20 again. Okay. So we're just going to add multiples of n, sort of, except there's something wrong here. Let's do that table thing again. Put a table in. So I have 1.36 and 1.56. Or what do I have to go until? 4.36. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 4.96 is 19. Oh, it's 1.36. 19, 18, 17. There's 16. So I'm going to do from 1 to 16. That'll add up 16 terms. But if I plug the 1 in there, the 1, I'm going to start at the wrong number, 1.56. That'll be the first one. You see, that's not going to be, let me just, yeah, so I can't start at 1. So I can do this. I can start at 0. Okay. If I start at 0, that gives me the right answer, right? I start at 0. But if I start at 0, I have to go back 1 to 15. 0 to 15, that's 16 numbers. Okay, 0 to 15 is 16 entries. If I want to do the same thing, but I want to stay and starting at 1, I can start at 1. I can start at 1 and go all the way to 16. That's definitely 16 numbers, 1 to 16. But all I have to do is get rid of one of the 0.2s. In other words, I have to take it back to the beginning of 0.2. So when I plug 1 in here, when I plug 1 into this equation, I get 1.16 plus 0.2 is 1.36. So that's the first thing I'm starting at. And what about the last one? What is 1.16? Copy. What if I plug 16 into there? What's that going to be? 436. That's where 4.36. That's where we wanted to stop. As long as you're beginning and ending at the same series, like if it's the first thing is the first thing you plug in and the last thing is the last thing you plug in, then you're probably right. Okay, let's just for fun do this and see if it makes sense. G of XP. Ooh, what if I add these up? That's a lot of adding up to do. 100. This is like 170, 240, 300, 400, 500, 600 and something. What did we say this was? 729. Sure. Okay. All right. Where's the homework? Okay, this one's just the summation you could do. This one starts at 3. So the first number you plug in is 3. So it's 7 times 9 plus 3. And the last one that you plug in is 7. 7 times 49 plus 7. This is another one. You just plug it in. Okay. Find the area under the curve on this interval. Okay, so here's how you find the area under the curve. You use the definite integral and you go from 0 to 1 and you just put h of x in here, dx, and it tells you the area. Okay. Then these two are things that are a little harder. I think we'll save them for next time because these are, there's some cool graphics in here, by the way. I want to show you something. No, let me show you. I have a minute or two. I'll show you, but I spent a lot of time on this trying to make life good. Make life good. So here's the function. So I want the area under the curve between 0 and 1. Okay, which is like okay, so between 0 and 1 is like all of these dots. Watch this though. This is kind of cool. Maybe it's not cool. What I want to do is it's not the function that I want. Too many things on and not what I want on. Desmos needs to turn everything off, but okay, so there's the function that I want. Okay. And what I'm going to do is I'm going to find a whole bunch of points between 0 and 1. Actually, that's only 3 points between 0 and 1. But I want more. I'm going to add, I want to take that interval and divide it up into 24 pieces. Okay. So if I click on this, there's the 24 pieces that I want. Isn't that cool? And I'm going to get the area of each one of these little rectangles. So I'm going to find out the height of the rectangles. Right? I click on them. I'm going to see how the little rectangles I made in there. So I have the little widths because they're 1/24 wide. And if I get the height here, these are what it's called from the left side. In other words, I just plugged in the left side of the function and then made a little rectangle. So I have these heights. So I can add up all those heights, multiply them by the width, and then I can get a really good idea of the area under the curve. Okay? And there it is shaded. Isn't that cool? The more rectangles I use, the better my estimate will be. Here's how I wrote that, how I would write that in Sigma notation, how to add it up, and I get 2.31. That's the area of all those rectangles. So I'm adding up all these heights, evaluated at 1/24. Okay. This is the same thing starting at a different number, but anyway, here's the area under the curve, the exact area under the curve. See how close that is? That's not bad. Anyway, Here's a picture of the exact area, just so you can see it. Actual green, see how they're very close? There's just a little bit of space in there. Okay. Anyway. I want you to think about that. What we're going to do, you can use all types of rectangles, but we're specifically going to use the rectangles. We're going to know how wide we are, and we're going to know how high up we're going. Okay, so we're going, the height is going to be the function. We're not going to use rectangles of different shapes and sizes. They're all going to be the same. All right, that's enough. Have a good day. Good luck with the test. What? What was it?
Holding.
What? Avocados numbers?
1023.
10 to the 23rd. They're stretching. That is a real stretch. At least pi day is 3.14. Like I can get that. 10 to the 23rd power food. Anyway, at least I know what you're talking about. All right, take care. Let me kill this. Anyone at home have a question?
I have a question.
All right, well, I'm stopping the.
Have a great weekend.
No, you can ask. I'm just gonna stop the live